Alright, so our goal for this video is to show why the division algorithm for decimals works. So we have 0.045 into 17.63921. In our previous definitions, we have defined division by a whole number and division with remainder by a whole number, but I don't know how to divide by a fraction or a decimal as is. So we need to make it a whole number. If I have 0.045, how do I make it a whole number? The algorithm tells me just to boop, 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 get rid of the decimal. If I do that on the outside, I gotta do it on the inside, three times, there we go. So I get 45 into 17,639.21. The decimal point is then fixed, and I carry on about my business. But why? Why does that happen? So real quick, we're going to go back to our handy-dandy friends, the decimal fractions, and look at what this says. So I have 17.63921 divided by 0.045. I'm going to write them as decimal fractions. And so we're going to end up with a complex fraction, right? Because this division means 17.63921 divided by 0.045. And now I'm going to write it as a complex fraction and see what's going on with that. So 17.63921 as a decimal fraction is 17.63921 over 5 decimals, so 5 zeros, 1, 1, 2, 3, 4, 5. And all of that divided by 45 over 3 decimals, so 3 zeros, so 1,000. All right, so there's my complex fraction. It looks pretty funky, but so like we said, we know how to divide by a whole number, so if I can make this a whole number, we'd be good to go. What's stopping it from being a whole number is that its denominator has zeros in it. How can I get rid of that? Well, I'm dividing by 1,000, so if I multiplied by 1,000, I would be good. That I don't want to change the overall value of a fraction. We know that if I multiply by 1, then I'm just taking one step of that size, which lands me at the same exact spot. We can then use our understanding of equivalent fractions and multiplication of fractions to simplify this. This bottom part of the complex fraction is being divided by 1,000, so if I multiplied this bottom by 1,000, those would cancel out, and I would have my whole number 45. Now I can't just have a denominator of 1,000, otherwise I wouldn't be multiplying by 1 anymore. So I could use equivalent fractions to rewrite 1 with a denominator of 1,000. So let's look at what that would look like real quick. So I'm going to write that 1 as an equivalent fraction with a denominator of 1,000. My first fraction stays the same, 1,763,921 over so we have this, and rewriting 1 as an equivalent fraction with a denominator of 1,000 would be 1,000 over 1,000. And now this is just multiplication of fractions, top times top, bottom times bottom. So on the top, I have 1,763,921 times 1,000 over all those zeros. All of that over 45 times 1,000 over 1,000. All right, so now we can simplify. If you watched the complex fractions video before, we have here a complex fraction, so I need to simplify the top and simplify the bottom before I attempt the whole fraction itself. I'm multiplying by 1,000 and dividing by 100,000. These, we can simplify this fraction. The numerator and the denominator do have a common factor, and it is 1,000. Simple way to simplify that, just cancel out the zeros. There we go, and you can watch some of the previous videos to see why that works. Now my numerator is just over 100. So I have 1,763,921 over 100. and all of that over. Now I'll simplify the denominator. 45 times 1,000 divided by 1,000. This was the whole reason why we did all that. The thousands will cancel, so I'm over 45. And now that complex fraction, again, just using my decimal fractions. In the numerator, I can simplify this fully. The 100 just indicates I'm going to have 2 decimal points, so I have 17639.21 over 45, which is the division we set out to do, right? So I have the fixed decimal point, I'm dividing by a whole number, and now I can set up that algorithm, or set up that division. So this is why that algorithm works.